In this question, we've been given some data in a table. The data represents the marks obtained by a group of students in two separate tests. We have test 1 and test 2, and the students have been labelled from A through to F. We're told the first test is out of 50 marks, while the second test is out of 30 marks. We've been asked to let X and Y represent the marks obtained in test 1 and test 2 respectively, and we've been given the following summary statistics. Now, I'm always going to want to write my own list that I can add to and I can use when substituting into formulas, so I'm just putting these at the top of my working out. In part A, we're asked to find the product moment correlation coefficient between X and Y. We need to find a value for R. So that means we need to find S of XX. S of XX, following the formula, will be sum of x squared minus the sum of x squared over n. Just substitute these in. 7,853 minus 235 squared over 8. S of YY we can find in a similar fashion. Substituting in all the right values, I can quickly compare them to the summary values that I've written at the top, so I know that I've got the right values in my working out and in my calculator. And lastly, we've got S of XY. And now that we've found each of those, we just need to go ahead and calculate R. So R, we know the formula is going to be S of XY over S of XX, S of YY. I always remember that the one with the two different variables is always in the numerator. Substituting in the values that we have, we get an R value of 0.789. So that is strong correlation. If we were asked to interpret it, we would say that's strong correlation. In part B of the question, we're asked to explain how the value of the product moment correlation coefficient, the value of the PMCC between X and Y, how will it be affected if the individual test marks were converted into percentage marks? So rather than being a raw score out of 50 and a raw score out of 30, if we change them both into percentages, how would that affect the PMCC? Well, we know that this is coding. So to code, we'll be dividing by 50 divided by 30. This is linear coding. And the PMCC is never affected by linear coding. Linear coding has no effect on the PMCC. So you wouldn't be expected to go and recalculate. You would just be expected to recognize that you wouldn't need to do any more calculations, to know immediately that the PMCC for the coded values is also 0.789.